Okay, so 6.6 at the top says analyzing graphs of quadratic functions. So when we were graphing these guys, when I put them into my calculator, we were graphing them before, they were all ax squared plus bx plus c. Okay, more like that guy down there. So when we started, we were graphing all of them. However, we have a form called vertex form. And vertex form, every quadratic function can be written as y equals a times x minus h squared plus k, where h comma k is the vertex of the parabola, and x equals h is the axis of symmetry. So think about like slope-intercept form of a parabola. Or of a line, right? I can look at y equals mx plus b and I can say, okay, I know what the slope is. I know what the y-intercept is, and I can graph him real fast. Think about this as that, okay? So, if I had a line, I can say, okay, that guy's my slope, that guy's my y-intercept, and I have a place to start. This guy, when I put it into vertex form, is the same thing. I have a vertex, and I have my axis of symmetry. I have a slope. I can look at this guy and graph him really quick. So think of him as like a quick way to graph. Okay? This box right here just tells you what happens to this graph as h and k and a change. So if k is positive, the graph moves up. If k is negative, it moves it down. If it's 0, it's just a plain old x squared. Okay? If h is positive, the graph moves to the right. If h is negative, the graph moves to the left. And then a, just like a before, when we were graphing them before, a, if it opens up, it's positive. If it's negative, it opens down. And then it also tells me how fat or how skinny he is. So if the absolute value of a is bigger than 1, think about it as if it were a fraction bigger than 1, then he's going to be skinny. And if he's a fraction smaller than 1, then he's going to be a fatty. So that a value, think about it as changing our slope. Does that make sense? So that's a whole lot. I'm not going to ask you to memorize, oh, what does k do, you know, if he's negative, that sort of thing. Okay. So number 1 there says graph and analyze y equals x minus 0 squared plus 0. All right, well, let's figure out what a, h, and k are. All right, so if there's no number out front, we assume that guy to be a 1. So there's a, there's h, and there's k. And that's just from this guy right here. So my vertex is at h comma k. I'm going to list them out. A is 1, h is 0, k is 0. So my vertex is at 0, 0. My axis of symmetry, it said, was x equals h. Okay, so x equals 0. And then the direction of opening, just like before, if he's positive, he opens up. Okay, so when we were graphing them before, we were graphing 5 points, right? We made our little t-table and we used our calculator and graphed 5 points. Now we're just going to graph 3. So we're going to start with our vertex. So you're going to graph your vertex. Should probably graph our axis of symmetry. We're going to use that a value to get the next 2 points. So one of the points has to be your vertex. The other 2 are the next 2 points from your vertex. Now, be careful because this only works for the next 2 points. So if it's 1, I'm going to go up 1, right 1, up 1, left 1. If you notice, I can't go to 1, 1, 1. I'll get a V shape. Okay, so you're only going to graph the vertex and the next 2 points using that a value as your slope. Okay, questions on that one? All right, let's do number 2. Number 2 says the same thing. Graph and analyze y equals parentheses x minus 3 squared minus 2. Now, be careful. In this guy up here, it says x minus h, and you notice how h is negative. However, when I pull him out, he's a positive h. So this guy flips his sign. Think about when we were doing synthetic division, right? And it was like divided by x minus 3, and then we put a positive 3 in our box. Same thing. When we pull this guy out of the parentheses, he flips his sign. Okay? So there's A, there's H, there's K. So A is 1, H is now positive 3, however, K keeps his sign, so he's a negative 2. This guy flips his sign, this guy keeps his sign. Okay, so my vertex is at positive 3, negative 2. Axis of symmetry, remember that's a line, so x equals h, so x equals 3. And my A is positive, so this guy is opening up. All right, so here I go. I'm going to graph my vertex. 1, 2, 3, 1, 2. Axis of symmetry. My A value is 1. I'm going to use that as if you were the slope. So up 1, right 1, up 1, left 1. Okay, questions on either one of those two? So it kind of makes graphing a little bit faster. Just like when we had slope-intercept form, you can look at it and say, okay, this is where I need to start. My starting point is my vertex, and then my A value, I can use my slope, and I can just sketch them in really quick. Okay? That's really cool if it gives it to us in vertex form, right? So even there was some on our homework, like in 6.2. Let me see if I can find it. Remember these guys from 6.2? These guys are already in vertex form. Okay, this guy says my vertex should be at -4, -1. Looky there, it was at -4, -1. Okay, this guy should have a vertex of +4, +1. So I would have a vertex there at 4, 1, and then he would open down. So you can look at it real fast and see where the vertex is and know what he looks like. Well, that's cool if they're given to you in vertex form, but is it always going to be given to you in vertex form? No, it's not. You guys are so smart, you know what math does to you. So, there at the bottom it says, given a function in the form y equals ax squared plus bx plus c, you can complete the square to write the function in vertex form. Remember, to complete the square, the coefficient of the quadratic term must be 1. So A has to be 1. If not, we'll force it to be 1. Okay, so number 3 says write y equals x squared plus 2x plus 4 in vertex form and then analyze the function. When it says analyze the function, that just means tell me the vertex, tell me the axis of symmetry, and which way he opens. Okay? Excuse me. All right. Here we go. Think about when go back to rewind your brain to completing the square. We're going to force this guy right here to factor into the two exact same forms. But instead of having a 0, we've got a y now. So what I'm going to do is I'm going to move that -4 to the other side. Or that 4, excuse me, to the other side. So he's now y minus 4. And save a little room because we're going to have to add in our box. Equals x squared plus 2x. So when we were doing it before we went to the right, now I'm just moving this guy to the guy side with the y. And then I'm going to add in a box to both sides. I want this side right here to factor to have the two exact same factors so I can write them as a perfect square. All right. Remember the formula for the box is b divided by 2 and then squared. So what's my b? 2. Thank you, Sasha. So 2 divided by 2 and then square it is 1 squared, which is 1. So I'm going to put a 1 in each one of my boxes. Okay, so now I have y minus 4 plus 1. Combine those guys so I have y minus 3 equals, I'm forcing this to factor like that. X, keep the first sign, square root the box. Now I'm going to move the 3 back over to the other side. So y equals x plus 1 squared plus 3. Hey, looky there. He's in vertex form. You did it. Now, when it says analyze a function, we just have to list 3 things. The vertex, the axis of symmetry, and which way he opens. Anybody want to take a stab at the vertex for me? What do you think? Close, Colden. Remember to flip the sign. Yeah, perfect. Thank you. Okay, anybody want to try the axis of symmetry? Sasha is showing me numbers. She says x equals -1. And then everybody point which way he opens. You have a 50-50 chance. Okay, what's the A value? What's the number out front here? 1. So is he positive? Yeah, he's positive. So he's going to open up. It's early, I know. If only you had study hall first period, right? Or PE or something like that. Okay, let's try another one. Turn the page. Are you good? Questions? Okay, before we do a whole lot with this one, look at number 4. It says write y equals negative 2 x squared minus 4x plus 2 in vertex form, and then analyze the function. All right, so just look at him really quick. What do we know about him really quickly? Which way does he open? Down, right? This guy's going to open down because we have a negative 2 out front. Okay, so we know that straight off the bat. We know he's going to open down. All right, so the other thing we have to look at, though, is we have a coefficient in front of our squared term. So we're going to trick this guy. All right, so the first thing I'm going to do is I'm still going to move my 2 to the other side. I'm going to move the constant to the other side. So I have y minus 2 equals a negative 2 x squared minus 4x. Now, it told me I can't complete the square when I have a coefficient out front. So I'm going to trick it, and I'm just going to divide these two guys right here by a negative 2. So really what I'm going to do is I think about like factoring. I'm going to pull him out front. So I have x squared plus 2x like that. So I'm tricking him. Really, he does have a coefficient, but I'm just tricking him so that he doesn't think that he does. Okay? And now I'm going to add in my box. Okay, well, let's talk about the left-hand side, though. I have a y and a minus 2. But if I were to FOIL this guy back out, or distribute, I would have negative 2x squared minus 4x, and then negative 2 times this box. So to preserve equality, I have to have a negative 2 times this box. So, let me see if I have another colored pen. I do. This right here and that right there help me keep equality. So anytime you have a coefficient out front, we're just going to factor him out front, but then I have to remember to put him in front of this box. So if he was a positive 2 here, I would have a plus 2 in front of my box. Okay? Did somebody have a question? A hand? I heard a beep. Oh, Abigail. Yeah. Yeah, so yes. So if it's a positive one, we don't have to do anything. If it's a negative out front, then we're going to treat him as a negative 1. If it's like a 5 out front, yeah. Perfect. Good question. Thanks, Abigail. Okay, now when we go to complete our square, we use the new b. So this guy right here. So don't go back and use the 4 because we've divided him out. So 2 divided by 2 is 1. Square it is 1. So I'm going to put a 1 in each one of my boxes. Okay, now, order of operations says that I multiply first. So this is negative 2 times 1. So that's negative 2 minus 2 more. So on the left-hand side, I have y minus 4 equals negative 2. Remember, I'm forcing him to factor. Into x, keep the first sign, square root the box. So x plus 1. And then final step, move your constant back over. So y equals negative 2 x plus 1 squared plus 4. Okay. All right, we already determined he opened down first because I had a -2 out front. Okay, so where's my vertex? Anybody want to take a stab? -1, 4. Awesome, thank you. And the axis of symmetry? X equals -1. Let's skip number 5. I should have taken that off of there. I haven't done that in a long time. I need to get rid of that bad boy. Ooh, that feels better, right? It's like an early Christmas present for you. Okay, last one. Graph and analyze y equals -4 x squared plus 16x minus 11. Whew. Okay. Is he in the nice pretty form? Not yet, right? But we could make him that way. We just have to complete the square. All right. We have the coefficient out front. So we have to divide him. You only divide him out of these two right here. All right, so I'm going to move my 11 over. So I have y plus 11. And then I have a -4, and I'm going to add in my box because I have -4 times x squared minus 4x plus my box. All right, make sure you understand where all of those numbers are coming from before I go any further. Yes, Romy. Okay, so you can also think about this guy as plus -4 times my box. So if I were going to, say where I were going to distribute this guy back out, I would have -4 times x squared, and then I'd have -4 times a -4 to get x to give me the positive 16x, and then I would have -4 times this box. So I need a -4 times my box on the left-hand side. Does that help, Romy? Or is it still fuzzy? Okay, you're welcome. Yeah, so I have to keep, remember with the equal sign, remember when you're in elementary school and they made you like do the whole thing with the balance, right? Whatever you do to one side of the equal sign, you got to do to the other side. So we're still trying to do that. It's crazy how, you think back to elementary school and you're like, oh, that's why they made me do that. Yeah, because right now I have to keep equality from this side to that side. Okay. So I'm just taking it out of these two guys and I'm kind of tricking it. Yeah, we're being tricksters. Show you what else you could do. Okay, so let me show you. If I divide everybody by a -4, like we were doing before, it would look like this. Right? Oh, a -4, that would be positive. Right? If I divided everybody. So here's what I had. I had y squared equals a -4x squared plus 16x minus 11, right? And if I divide everybody by a -4, where is lady? Stop. Have some more coffee. Okay, that's what we did before, right? Except for it was a 0. Yeah? Okay, so here's what I would have. I would have y divided by a -4, and then I could move that over. Plus 11 over 4. No, that would be a minus. equals x squared minus 4x, my box. Right?
Yeah.
Okay. It gets a little gross, but you can still do it this way. When we keep going here and we fill in our boxes, we'll get to a point where we'll have to multiply by a -4 to get rid of this guy right here, and he'll just end up going back out front. So I'll continue to do it both ways so that you can see it. Let's do it this way first, and then I'll finish this way so you can see it. Don't have to. You trust me. Okay, I like that idea. Okay, so I'm using my newbie here. 4 divided by 4. I know I lied to you. 4 divided by 2. And then square it. 4. Awesome. So I'm going to put a 4 in my box. So I have y plus 11 minus 16 equals -4 times x minus 2 squared. Okay, so y minus 5 equals -4 times x minus 2 squared. Move your 5 over. Okay. So my a is -4. My h, flip the sign, is a +2. And my k, keep the sign, is a 5. So where's my vertex? Two, 5. Perfect. Axis of symmetry. Perfect. And which way does this guy open? He's negative. Down. Okay, so I'm going to graph him. +2, +5. Here's my axis of symmetry. Now, my a value is -4. So I'm going to use that as my slope. I'm going to go down 4, left and right 1. So this guy's skinnier. Remember I told you if he's bigger than 1, the skinnier he gets. And if he's more of like a fraction that's less than 1, so like 1/3, he's a fatty. That makes sense? So I use this value right here as the slope. Yeah, Sasha. Let's look at your homework. I would say if I'm gonna have you graph something, I'll give you the fraction out front. So I won't have you divide out the fraction, but let me check your homework just to make sure. All of the ones, here's your homework. So like on this one, he's already in the right form. You don't have to complete the square. So we'll do that one together here in just a second, okay? So if I'm gonna have you graph it with a fraction right there, then I'll give it to you in this form. I won't make you complete the square with a fraction coefficient. Does that make sense? You're welcome. Okay, questions on your notes before we look at your homework? Yep. Remember, we got to preserve equality. So I'm forcing, I need this side to factor so I can write him as a perfect square. So before I add in the box, he would look like that. So I have to add in the box so I can write him as a perfect square to get him in the right form. And once I add a box to the one side, I have to add a box to the other side. This box just happens to have a -4 out front. Okay, anything else? Okay, let's look at your worksheet. Some of these are already in the right form. So I'm going to tell you which ones you have to complete the square on. Okay? Number 1 is already in the right form. You can add a 0 if you want. So my A would be 1, my H would be +2, and my K would be 0. Okay? This guy right here, number 2, he doesn't have a plain old x. The only time you have to complete the square is when you have a plain old linear term, an x term. So this guy right here, I'm going to give him a 0 as well. So watch what happens. Negative, I'm going to put a -1 so you can see it. But he is x minus 0 squared plus 4. So I just put -0 with that guy. Does that make sense? Make sure you see where that's coming from. Same thing with 3. I don't have to complete the square with 3. I can just put x minus 0 squared minus 6. Okay, 4, I'm just going to put plus 0. 5, I'm just going to put x minus 0 in. So I have -5 times x minus 0 squared plus 9. 6 is in nice, pretty form. 7 is the first one where you have to complete the square. 8, you have to complete the square. See how they have plain old x terms? 9, you have to complete the square. Would you like to do number 9 together? Yes, okay. These two don't have a coefficient out front, so you just add 5 over, add in your box. Subtract the 2 over, add in your box. Number 9 has that -3 out front. Okay? He also doesn't have a constant. You can put a plus 0 if you want, but it would just be like adding 0 over to the other side, and then I'm going to add in my box. So this guy is going to be y. I have a -3 out front, so this is going to be -3 times my box equals -3 x squared. 24 divided by -3 is a -8x plus my box. Oops, sorry. Is that okay? You okay with that? Ish. You're okay-ish, my guess is. Good question. See how this guy has a plain old x with him? And that guy has a plain old x, so I have to complete the square. So I'm trying to get it to look like that. So if I can just add zeros in to get him to look like that, then I don't have to complete the square. This guy, I can't. I have to complete the square because I have that x term. You're welcome. Okay, so now I'm going to use 8. 8 divided by 2. 4 square 4, so I'm going to put 16 in my box. All right, 3 times 16, 30, 48. -3. I'm forcing him to factor x. Keep the first sign, square root the box. So y equals, oh no! Did I freeze? Oh, I'm sorry. Oh, so wheat. Okay, am I coming back? Is it better? I sound normal now. Okay. Okay. I'm going to. Okay. Now I'm going to move the 48 over. So I have y equals -3 x minus 4 squared plus 48. Okay, so the instruction says write it into vertex form if it's not already in that form. So that's where you're going to complete the square on those 3. And then it says identify the vertex, the axis of symmetry, and which way he opens. Okay, so this guy, the vertex, is at +4, +48. The axis of symmetry is x equals 4, and this guy opens down. Oh, sorry. Okay. So when you get down to the bottom, all you have to do is graph it. 10's in the right form, 10's in vertex form, 11 is in vertex form, 12's in vertex form, 13 is in vertex form, and I will help you do 13. 14 is almost in vertex form. I'm just going to give him a 0. So when you graph 14, excuse me, I just threw a 0 in for you. And then 15, you'll have to complete the square. And I told Sasha I would help you graph number 13. So let's graph 13 really quick. Okay, so where's my vertex on 13? It'll be at -2, 0. And then I have a negative, so it opens down, and it's -1/2, and I'm going to treat that guy as my slope. So I'm going to go down 1, left and right 2, so he's fatter.